The age-old question, are we alone in the universe, has captivated human imagination for millennia. From ancient myths and philosophical ponderings to modern scientific inquiries, the idea of life beyond Earth has been a constant source of fascination and wonder. Today, with the rapid advancement of technology and our expanding knowledge of the cosmos, the quest to find extraterrestrial life, be it microbial organisms or intelligent civilizations, has transitioned from the realm of science fiction to a rigorous scientific endeavor. Now, before we get too excited, let's talk about the challenges we face in this epic quest to find extraterrestrial life. While the idea of discovering life beyond Earth is thrilling, the reality is that it's far from straightforward. The universe is a vast and complex place, with an estimated 100 billion galaxies, each containing millions or even billions of stars. Among these stars, many have planets orbiting them, some of which might lie within the so-called habitable zone, a region where conditions could be just right for life as we know it. However, pinpointing exactly where life might exist in this colossal expanse is akin to finding a needle in an almost infinite haystack. One of the most significant challenges in our search is the sheer scale of the universe. Even within our own galaxy, the Milky Way, distances between stars are measured in light years, with 1 light year being nearly 6 trillion miles. This makes direct exploration of planets outside our solar system currently impossible with our existing technology. For instance, the closest star system, Alpha Centauri, is about 4.37 light years away. With current spacecraft speeds, it would take tens of thousands of years to reach even this nearest neighbor. Thus, any hope of detecting life must rely on indirect methods, such as analyzing light from distant planets or searching for signals that might indicate intelligent civilizations. Moreover, space is not just vast but also incredibly empty and dark. The majority of the universe is made up of voids with very low density, making it difficult for us to detect anything that isn't emitting a strong signal or reflecting light. Even if we were to detect a signal or see something unusual, distinguishing it from the myriad of natural cosmic phenomena would be a daunting task. Cosmic noise, random radiation, and signals from stars, galaxies, and other celestial objects can easily drown out potential signs of extraterrestrial life. Our instruments must be extraordinarily sensitive and sophisticated to pick up these faint signals, and even then, there's no guarantee that we'll correctly interpret what we find. Another hurdle is the limitation of our current technological capabilities. Although we've made significant advancements in recent years, we're still in the early stages of developing tools and techniques to search for extraterrestrial life effectively. For example, the search for extraterrestrial intelligence, SETI, has been ongoing for decades, scanning the skies for radio signals that might originate from intelligent civilizations. Despite this, we have yet to detect any definitive signs of extraterrestrial intelligence. One of the most promising tools in this quest is the James Webb Space Telescope, which has already started to unveil wonders about our universe since its launch. The JWST is equipped with a suite of powerful instruments that allow it to observe distant galaxies, stars, and planets with unprecedented clarity. Its ability to analyze the atmospheres of exoplanets is particularly exciting, as it could potentially detect signs of life, such as oxygen, water vapor, or methane, in these distant worlds. The JWST's observations could be a game changer in the search for life. By studying the light that passes through an exoplanet's atmosphere, scientists can determine its composition and search for biosignatures, indicators of life. For instance, the presence of oxygen alongside methane in an atmosphere might suggest biological processes, as these gases tend to react with each other and would not coexist naturally for long periods without being replenished by living organisms. In essence, the JWST acts as a superpowered magnifying glass, allowing us to peer into the atmospheres of distant planets and look for the telltale signs of life. In addition to the JWST, other missions are underway that could provide crucial insights into the possibility of life elsewhere in our solar system. One such mission is the European Space Agency's Jupiter Icy Moons Explorer, set to explore Jupiter's moons, particularly Europa, Ganymede, and Callisto. These moons are believed to have subsurface oceans beneath their icy crusts, making them intriguing candidates for hosting life. Europa, in particular, has been a focus of astrobiological interest due to its potential for having liquid water in contact with a rocky seabed, creating conditions that might be similar to hydrothermal vents on Earth, where life thrives despite the lack of sunlight. The JUICE mission aims to investigate these moons in detail, analyzing their surfaces, ice shells, and potential oceans to determine if they could support life. If we find even microbial life beneath the ice of these moons, it would revolutionize our understanding of biology and the conditions necessary for life. It would also raise the possibility that life could be more common in the universe than previously thought, potentially existing in many more places than just planets with Earth-like conditions. Now let's talk about what's coming up in 2024 that could truly change everything we know about life in the universe. Mark your calendars, folks. In 2024, NASA is set to launch the Mars Sample Return Mission, a highly anticipated mission that aims to bring back rock and soil samples from the surface of Mars. This mission represents a significant leap forward in our ability to study the red planet and its potential for past or present life. While previous missions like the Curiosity and Perseverance rovers have provided invaluable data, bringing actual Martian samples back to Earth would allow for more detailed analysis using the full range of advanced instruments available in laboratories around the world. The Mars Sample Return Mission could provide us with direct evidence of past life on Mars. Scientists are particularly interested in ancient lakebeds and river deltas, where water once flowed and where signs of life might be preserved in the rock. Imagine if we were to find fossils, microbial mats, or chemical signatures that indicate the presence of life billions of years ago. Such a discovery would be a game changer. It would suggest that life can arise on other planets and that the processes that led to life on Earth might not be unique. In addition to the Mars Sample Return Mission, these missions and discoveries have the potential to fundamentally alter our understanding of the cosmos and the possibility of life beyond Earth. It's an incredibly exciting time to be a space enthusiast. The combination of new technologies, upcoming missions, and the increasing focus on astrobiology is bringing us closer than ever to answering one of humanity's most profound questions. Are we alone in the universe? While challenges remain, the progress we're making is astounding, and the next few years could bring discoveries that reshape our understanding of life in the cosmos. Thanks for joining us on this journey into the unknown, exploring the question that's been on humanity's mind for centuries: will we find aliens? As we venture further into space and push the boundaries of our understanding, one thing is clear: every discovery brings us one step closer to answering this age-old mystery. If you enjoyed this video, don't forget to hit the like button and subscribe to Mars Discoveries for more fascinating content about space, science, and the search for life beyond Earth. And if you've got your own theories about extraterrestrial life, drop them in the comments below. We'd love to hear what you think. Until next time, keep looking up, stay curious, and remember, Mars might be just the beginning.